A silver ribbon rises beside a boat, its red crest trembling, while an impossibly long body vanishes beneath dark water. For a startled witness, the moving line can become a serpent before its identity becomes a fish. If you glimpse only one curve between waves, distance and fear can complete an animal that was never there. The giant oarfish, Regalecus glesne, offers a real biological source for some sea serpent imagery. It cannot explain every historical report, and no single species can retroactively identify poorly documented encounters. Yet its form reveals how an unfamiliar ocean animal can acquire scales, coils, speed, and intention through retelling. The mystery lies between body and story. Which details belong to oarfish, and which entered through perception? We begin with verified anatomy, then test sightings, behavior, strandings, and the persistence of legend. Each step removes one imagined feature while preserving the genuine strangeness swimming beneath it. An oarfish is elongated, but not snake-shaped in construction, because its body remains laterally flattened like a blade. A red dorsal fin runs along much of the back, beginning with tall rays that form a crest. Its small mouth and delicate skeleton contradict tales of a powerful monster attacking ships. The animal can nevertheless appear enormous when few familiar objects provide reliable scale on open water. Our investigation follows that transformation without treating folklore as zoological proof. Regalecus glesne occurs broadly in temperate and tropical oceans, usually away from shallow coastal habitats. It belongs to lampriforms, an order that also includes oppas and several other distinctive pelagic fishes. Its long body carries many vertebrae and supports an extended dorsal fin used for propulsion and control. Pectoral fins are small, while the pelvic fins are elongated and may resemble narrow streamers. Despite the common name, those pelvic structures are not broad oars driving the fish through water. The origin of the name is historically debated, so confident explanations should remain cautious. Verified video shows living oarfish holding nearly vertical positions with the head above the trailing body. Undulations pass along the dorsal fin, while the trunk remains comparatively straight. This movement allows controlled hovering and slow translation without large side-to-side body bends. When you see only the red fin crest breaking a surface, its sequential waves can suggest many separate humps. That cue reaches an observer. The brain groups fragments. Familiar serpent imagery supplies continuity, and memory preserves a creature. The sequence describes human perception rather than deceit, especially under surprise, glare, distance, or rough seas. Oarfish skin is silvery and easily damaged, producing irregular dark patches after capture or stranding. Those marks can be mistaken for scales, wounds, or patterns depending on lighting and decomposition. The fish lacks the massive tail and muscular profile expected of a fast-surface predator. Its jaws are suited to feeding on small prey rather than biting large vertebrates. Stomach evidence indicates consumption of zooplankton, including small crustaceans, along with other small pelagic organisms. The mouth extends during feeding and creates suction that draws nearby prey inward. Sensory detection guides orientation. Jaw expansion moves water. small prey enter, and delicate structures retain the meal. This feeding sequence produces no behavior resembling deliberate pursuit of ships or people. Specimen anatomy establishes these features directly, while preserved condition can alter color and softness. Video supplies posture and movement, although most recordings are short and may involve weakened animals. Genetic identification can separate damaged oarfish from other elongated fishes when outward features are incomplete. Environmental records around strandings can test conditions, but correlation never establishes a cause by itself. Historical sea serpent accounts present a different quality of evidence. Some include drawings, measurements, or collected tissue, while others survive only as retold descriptions. A witness may accurately report a long silver animal, yet estimate length poorly without a fixed reference. Several animals traveling in line can appear to be one segmented body. A whale's back, drifting kelp, floating debris, or known sharks can also create serpentine impressions. These alternatives do not prove any particular account false. They show why descriptions rarely identify one cause. Where an intact specimen was recovered, an oarfish identification can be strong. Where only words remain, matching selected features is a hypothesis constrained by missing information. Long red rays fit some descriptions of a mane, while the flattened body fits reports of a ribbon. However, repeated claims of violent coiling conflict with the limited movement documented in living oarfish. Reports of raised heads may fit vertical posture, but perspective can also convert a nearby crest into a neck. The scientific task is not to choose the most dramatic match, but to compare all surviving details. It also explains why better observation can transform monsters into animals without making early witnesses foolish. Human vision evolved to complete partial shapes rapidly, a useful ability that can misclassify rare scenes. Memory then emphasizes distinctive elements and loses ordinary transitions, especially after repeated conversation. Illustrators add coherent anatomy to verbal fragments, giving later readers an image no original witness actually saw. Printed accounts can copy earlier motifs, making independent incidents appear more consistent than they were. Thus, resemblance among stories may reflect shared cultural templates as well as shared marine animals. No statistical method can recover details that were never recorded or separate observation from later editing perfectly. The oarfish hypothesis is strongest when specific anatomy appears before the animal became widely familiar. Even then, resemblance supports an explanation rather than proving the identity of a vanished encounter. Modern cameras improve the evidence, but unclear images still require scale, location, sequence, and diagnostic features. A long, bright streak in one frame is not automatically Regalecus glesne. Likewise, acoustic contacts reveal reflecting objects, not colors, fins, or folklore identities without additional data. Verified discoveries depend on converging evidence rather than the emotional force of a single mysterious trace. You may hear that deep-sea fish flee rising geological danger and appear ashore as warnings. Individual strandings have occurred before some earthquakes, while many others occurred without subsequent damaging events. Earthquakes also happen without nearby oarfish strandings, undermining a simple predictive relationship. Systematic analyses have not established oarfish appearances as reliable earthquake forecasts. The animals may strand because of illness, injury, currents, storms, temperature changes, or other environmental stress. Multiple causes can operate together, and decomposition often erases evidence before examination. An abnormal cue may change swimming. Currents carry a weakened fish, waves beach it, and exposure completes mortality. That documented general pathway needs case-specific evidence before any trigger can be assigned. If seismic activity affects some individuals, the mechanism and predictive value remain unproven. Turning coincidence into warning can distract from established earthquake monitoring and preparedness. It also reduces the fish to an omen instead of investigating its actual pelagic ecology. Living oarfish likely participate in food webs by consuming small drifting animals and becoming prey or carrion themselves. Their tissue transfers energy gathered from planktonic communities into larger predators and scavengers. Marks on specimens sometimes suggest predator encounters, but assigning the attacker requires clear diagnostic evidence. The long body may reduce turning speed, while vertical hovering could help inspect layers of concentrated prey. Changes in light, current, or prey density may trigger fin undulation and depth adjustment. The extended dorsal fin provides continuous control, allowing the fish to reposition without vigorous trunk movement. This cue action adaptation consequence sequence is visible in general form, though natural prey capture remains sparsely recorded. When you replace the serpent with that hovering feeder, the open ocean becomes stranger and more coherent simultaneously. Future evidence should prioritize long observations of healthy oarfish far from shore. Stable low-light video could document depth changes, group behavior, feeding attempts, and responses to predators. Accurate scale from paired cameras would prevent the size inflation common in isolated surface footage. Fresh stranded specimens examined promptly could distinguish injury, disease, starvation, and post-mortem damage more reliably. Genetic sampling could clarify population connections across ocean basins without relying only on external appearance. Environmental monitoring around strandings could test current, temperature, oxygen, storms, and seismic timing under one consistent framework. Large datasets would reveal whether any proposed association exceeds what coincidence and uneven reporting can produce. Historical accounts could be re-examined with attention to original wording rather than later illustrated versions. Researchers should record which details were witnessed directly, which were inferred, and which appeared during retelling. If you return to the silver ribbon, its real dorsal waves are enough to explain why imagination awakened. The fish need not raise a dragon's head, crush a hull, or predict the movement of faults. Its damaged skin can shine like armor. Its crest can resemble a mane, and perspective can lengthen every curve. Those visual matches make oarfish a credible source for some reports, not the solution to all sea serpent stories. Every unidentified encounter retains uncertainty proportional to the evidence that survived it. Modern verified footage gives Regalecus glesne posture and motion that old sketches could only approximate. Anatomy rejects the attacking monster. Ecology replaces omen with organism, and perception explains much of the transformation. Still, deep pelagic lives remain poorly observed, leaving ordinary behavior more mysterious than the legends surrounding it. The honest final image is a real oarfish undulating beneath the surface, while centuries of serpents remain only partly explained.